Welcome everyone, this is Development Economics. Today we're continuing our discussion of geography and development, focusing in particular on the influence of disease. So this graph shows something quite remarkable. GDP per capita increases with distance from the equator. And this is not just a northern hemisphere effect, it happens in the southern hemisphere as well. Though clearly you can see here is the United States and the northern hemisphere is very rich. Here is Japan, also in the northern hemisphere, is rich. This is Canada, Italy, France, and so forth. These are all rich countries in the northern hemisphere. Over here, however, in the southern hemisphere, we also see as distance from the equator increases, so does GDP per capita. This is Australia, New Zealand. This is Argentina, which is not a terribly rich country. Nevertheless, it's much richer than countries which are closer to the equator. Now down here, you can't even tell what these countries are because there's so many of them, but that's precisely the point. You see an awful lot of very poor countries close to the equator. Naturally, there are exceptions. This is Singapore, which has excellent institutions and manages to avoid the rule, the exception. Here is Hong Kong. This is Equatorial New Guinea, which has lousy institutions, but is nevertheless quite rich per capita, although the inequality is extreme, because it has a lot of oil. You can see the same relationship on this graph, which simply adds circles which are proportional to total GDP. So you have a lot of very rich countries up here and very poor countries down here. Notice, by the way, that even going from the equator to a country like Argentina, we're talking about going from $1,000 or so per capita GDP to $10,000. So there are big differences even within this small range over here. So why is this? Why does GDP per capita increase with distance from the equator? Here we see the same data, but in a map form. And once again, outside the Tropic of Cancer in the northern hemisphere, we see lots of rich countries. And outside the Tropic of Capricorn in the southern hemisphere, we see richer countries. By the way, one wonders if there had been more mass down here, another continent down here, whether we might not have seen more rich, far southern countries. You also see in the middle, in the equatorial regions, great poverty. Well, why is this? Let's take a look at the malaria index. What you see immediately is that the malaria index is almost perfectly inverse to the GDP per capita. Now this index, it's not the number of people who get malaria, which also depends upon GDP per capita. Instead, this is an index of where malaria breeds, where the temperature and the water conditions are such as to make the mosquitoes, which transmit the malaria, really very prevalent. And it's where where malaria likes to be. And where malaria likes to be is in the equatorial regions, particularly in Africa, but also in Asia and in South America. Now, malaria is a terrible disease. It affects 300 to 500 million people every year. And every year, those 300 to 500 million people, they're out for a week, completely incapacitated. And then for a week or 2 weeks after that, they're highly fatigued. 1 million of them will die, often young children. For the young children who survive, nor is this the end of the story, because once you've had malaria, even if you survive it, it may permanently stunt your growth and lower your IQ. So we begin to see here how a disease might have influenced development. And it's not just malaria. Here's a list of diseases which are more common in the tropics. Malaria, we just mentioned, yellow fever, Chagas disease, sleeping sickness, river blindness, snail fever, parasitic worms like roundworm, hookworm, and whipworm. These worms, over a quarter of the world's population is infected with at least one of these worms. About 1.4 billion people have roundworm, and about 1 billion have hookworm, and another billion or so have whipworm. Sometimes they have more than one. These worms, they infect the intestinal system. They drain people's energy. They reduce their ability to get nutrients. They take the vitamins that people eat and people consume, and they suck them up. They stunt growth. They reduce people's IQ, and make it harder for them to develop. They make it easier to get other diseases. Pretty horrible diseases. That's a picture of roundworm. Pretty terrible stuff. It's not just the direct effect of disease which matters. In development, we can have both virtuous and vicious cycles. Here's an example of a virtuous cycle. Good health leads to productivity. Productivity leads to high GDP per capita, and high GDP per capita feeds into good health through investments in medicine, through investments in public infrastructure, and just in better health in general means you're able to withstand the slings and arrows of outrageous fortune, which otherwise would kill you. When you have good health, you can withstand them and you're not so bad off. Good health also means that you can expect to live for a long time, and that leads to savings and to investment. And savings and investment, again, lead to high GDP per capita, which reinforces good health. That's a virtuous cycle. Let's take a look at one of the vicious cycles. Here, when we start off with disease, with malaria and yellow fever and worms and so forth, that leads to morbidity and mortality, which of course lowers GDP directly. It also means low savings. It means stunted people, especially when they've been hit by these diseases as young children. It means low IQ. This again leads to low GDP per capita. Low GDP per capita means you don't have the money to invest in sewage plants, to invest in clean water, to invest in vitamins, in vaccines, and all of the things which can improve health. So here we have an example of a vicious cycle. Disease leads to poverty, and poverty means it's very hard to get out of the disease cycle. There are many channels, by the way, in which this can work. So especially when you have a lot of children dying, women then tend to have more children to make up for the fact that some of them are dying. And when they have a lot of kids and a lot of them are dying, it frankly doesn't make sense to invest a lot in any one of those children. You're going to be worried when a lot of your children are dying that if you invest a lot in their education, in their human capital, then they're going to die and leave you with nothing. So mortality leads to high fertility, which leads to low schooling, which again leads to low GDP per capita and means you don't have the investments to reduce disease. That's an example of a really vicious cycle. It's said that the tropics are worse for human diseases. Not surprisingly, it also turns out they're worse for diseases that attack animals and crops. Now, we often think of the tropics as being lush, and indeed they are, but they're also chaotic. There's also a lot of death going on in the tropics. So it's much harder in the tropics to create single crops because they're invaded by these diseases and by these parasites. In fact, it turns out that some frost is actually very good for agriculture and very good for GDP. What frost does is it gives the crops which you want to produce, it gives them some breathing room. It kills off the parasites. It kills off those worms. It kills off those diseases. And even though when you have frost, you get a shorter growing season, it turns out that the absence of diseases overall means that you get higher productivity. So holding labor and capital constant, you actually get more agricultural productivity in the outside of the tropics than you do within the tropics. And in particular, in regions where there's a little bit of frost, not a lot, but a little bit of frost, you can actually get much higher productivity. Bear in mind that, going back to our Jared Diamond talk, that even today, wheat, corn, and rice form a huge bulk of our caloric intake. And wheat grows better in the more northern climates, so does corn, and even rice, though it depends upon the variety. Some varieties of rice actually also grow better in the northern climates. So, is geography destiny? No, it is not. But geography does matter. I like to think about it in the following way. The guy on the right, that's Tyrone Muggsy Bogues. He was 5'3". He played 10 seasons in the NBA, and yes, he could dunk. So is it impossible for a player of 5'3" to make it in the NBA? No, it is not. Do we see a lot of short players in the NBA? No, we do not. Muggsy was able to overcome his inherent disadvantages and play at an incredibly high level. I kind of think of Muggsy as the Singapore of the NBA. Muggsy was hitting way above his height class in exactly the same way that Singapore is hitting above its GDP per capita class. The other guy in the picture, by the way, that's Michael Jordan, who is actually a little bit shorter than the average NBA player. So, institutions clearly matter. All of the other things we've been talking about matter. In particular, communism really stunts growth. So if you take a look at some of our earlier figures, you'll see China and Russia are way below their GDP per capita, which you would expect, given their really quite favorable geography, given their really quite favorable climate and location and so forth. So communism stunts. Corruption stunts. There are a lot of countries who are doing worse than they could. Think about it this way, geography is potential, but you need good institutions to live up to your potential. There's also another twist, and that is geography can actually influence institutions, can shape some of those institutions. And we'll be talking more about that next time. Thank you.